Hello everyone. I'm Vidushi Patel, a PhD student at UWA. Brian's my supervisor. Today I'll be talking about an agent-based model of migratory beekeeping in Western Australia. So just to give a quick overview, the bee industry in Western Australia is basically growing very rapidly, but resources, basically the beekeepers target, they are mostly located in the southwest corner of the state, and beekeepers follow migratory patterns to chase flowering events that occur over the year, and different species also contribute to those migratory patterns. So this is part of one of the paper that we recently published, and it's based on the beekeepers' interviews and data collected from that. So with that migratory patterns, beekeepers create certain spatial patterns when they move across the landscape. So and there are some different pressures that are reported during that interview process, and most of them, like majority you can see here as burning of resources, availability and access to sites, and climate change and land cover change. So if we see that, we can see that these pressures are mainly affecting the forage resources itself, and then the effects get translated because everything is connected, and their livelihood is totally dependent on the forage resource and the condition of the forage resources. So we just try to investigate how does the change in this forage resources fit any pressure that can reflect in the spatial patterns of how they migrate around the landscape. Few methods we took here. So in an agent-based model, we have 3 elements in agent. That can be a human, can be animals, can be organization, company, institution, anything can be represented. And then environment, it can be spatial environment, network environment, or there are a bunch of decision rules or say interaction rules that based on that agents can interact with each other or interact with the environment. So one of the major main important use of agent-based model is that it can incorporate local level interactions and explain you how the system level results emerge from those local interactions. That's what we want to see here for beekeepers' interactions with the forage locations. So there are a bunch of different ways we collected data because it's very data savvy. So we did interviews and listed out a few target species that they target. We listed out 30 target species that beekeepers target. Then we did participatory mapping exercise with them using their EPRI site coordinates and understanding that which sites they use, what species they target on each of the sites, and then what month of the year that they target those sites. So that points of data, and then we downloaded some, for those 30 species, we downloaded point locations from Atlas of Living Australia, and then merged those coordinates and run into the model, species distribution model. So we compiled 30 species distribution model using current bioclimatic variables as well as future bioclimatic variables, and then created 2 different scenarios, that baseline and future scenario, just to see that how change in forage availability relative to climate may impact their spatial pattern over the time. Then we combine all those 30 species based on their flowering months they flower using Python, and then put it as a input layer in agent-based model for the applying decision moves. So first let me just give you a quick overview. This is a staked STM species distribution model for all the 30 species, and which shows that for each month what change you can see here. So we can see here that most of the change in the species occurs in here in the eastern side. So the green portion is where you can see flowering species occurring in individual months, and based on the decisions, beekeepers move their hives to different locations, and the output we are trying to see is that how for each run how far they want to travel and how it affects their travel distance, and also how it changes the harvest locations. Thank you.